Hello, I'm Ben Phillips with Union University School of Education. In this video, we're going to talk about the importance of statistical significance. In particular, we'll take a look at what this whole concept of statistical significance means. We'll talk about how it's measured in terms of p-values or probability values, and then what this looks like in education when we're talking about using inferential statistics. We're going to dig in a kind of an unusual spot, maybe an odd place for the beginning, and that is I want to tell you a little bit about one of my favorite fast food restaurants. You may be familiar with Steak Escape. So Steak Escape is this restaurant. It's typically found in food courts of malls, and it's where you go through and they serve kind of their specialty Philly cheesesteaks. And so you order and then they make it right there in front of your eyes. You watch them as they grill it all up and put it on the hoagie roll and the cheese and the whole bit. And it's one of my favorites, and it has been since I was a kid. I loved it, and every time I went to a mall anywhere, any city I was in or any place where I was on vacation, and there was a Steak Escape, I knew exactly what I was having. The interesting thing about Steak Escape, first of all, we used to have one here in Jackson, so our Jackson Mall is not quite what it used to be, but back in the day when it was a really nice mall and had a great food court, there was a Steak Escape there. And so there was this campaign, I guess kind of like a marketing campaign that the folks from Steak Escape put together related to their French fries. And if you've ever eaten at Steak Escape, you may very well know they have some great French fries. And their marketing campaign was they had this banner that hung right next to their menu, and the one here in Jackson in the 90s said, "Jackson's favorite fries." During that same time, I was in college at the time and went to different places and weekend getaways, and so I remember the mall in Nashville that had the Steak Escape. There were actually a handful, and there were malls in Memphis and even in Chattanooga, and every single city had their very own banner, of course, saying either Nashville's favorite fries or Memphis's favorite fries or Chattanooga's favorite fries, or I presume nationwide wherever they had these Steak Escape franchises. And so the interesting thing about that claim is I really wonder if you actually talk to the people at the Steak Escape restaurant if they had any evidence to back up their claim. So imagine the person who's like the skeptic and wants to determine if there really is something that we could use to figure out if they actually have Jackson's favorite fries. And so just say hypothetically, we were to walk up to the manager of the store and say, "I've noticed your banner, and can you tell me, how do you know that? Or what evidence can you cite to support that you really do have Jackson's favorite fries?" Well, imagine how shocked you might be to find out as a response from the manager that they've actually conducted studies. And their studies were some type of French fry challenge, where they had people just in a blind taste test try their Steak Escape fries against a competitor. You may notice in the picture right next door, it looks like there's a McDonald's, so we can just use that for our example. So the manager says, "You know what? We ran people through our little taste test, almost like, remember the days of the Pepsi challenge? And instead of it being a drink, Pepsi versus Coke, it was our French fries versus McDonald's French fries. And then what we did was, after we did our study, we turned all of our numbers over to our number cruncher. And so here's the number cruncher. He works at corporate or something like that. And he put all of our numbers together and did the analysis for us statistically and came back with the final report that we do indeed have Jackson's favorite fries." Well, let's imagine then that we prompt the manager for a little more information and say, "Well, I'd like to know some of those numbers. Could you tell me specifically what you found, and what were some of the exact pieces of data that helped you determine that you have Jackson's favorite fries?" And he says, "Well, sure, we'll share all that information." What we did was we had 10 people come through our taste test challenge. 6 people said that they liked our fries the best. Only 4 people chose McDonald's. And since we had the majority, we made the claim that we have Jackson's favorite fries. Now, as you're thinking through this for the first time, are you a little bit skeptical of this claim and thinking like, no way, you can't be serious? There's only 10 people in the study, and the 10 people were split 60%, 40%. It's a 6-4 split. If one of those people on the Steak Escapes had changed their mind or, in a second run chose something different, it'd be a 5-5. It'd be totally even. I think you can all see from the example that with only 10 people in a 6-4 split, that's really not enough evidence at all to make the claim that you have Jackson's favorite fries. And so let's imagine that the answer was a little different, and in fact their research numbers were a little bigger. So what if the manager said, well, here's the data. We surveyed 100 people in our taste test challenge. 60 people said that they liked our fries the best, and only 40 people liked the McDonald's fries. Since we had the majority of people, we made the claim that we do indeed have Jackson's favorite fries. What do you think about those numbers? Are you convinced? Most people are not. So only 100 people coming through the taste test. We're talking about speaking for this major metropolitan city here in terms of West Tennessee. And so 100 people really is not enough to speak into or speak for the entire population of the city of Jackson. Plus, the difference between those two numbers is percentage-wise the same, right? 60% and 40%. So what if the manager had said we did this? We talked to 1,000 people. We had 1,000 people do our taste test challenge. 600 of those people chose our Steak Escape fries, and only 400 people chose McDonald's. So since we had a clear majority, we decided to make the claim that we do indeed have Jackson's favorite fries. Well, if you're tracking with me, I think you get to a point here where you say, well, you know, I have to admit that's a little better. That's some more substantial evidence than the first example of only having 10 people to have data on. We now have 1,000 people, and 600 of those have said that they do indeed have Jackson's favorite fries. And so maybe we're getting close, but others might say, I'm still not convinced. After all, Jackson currently has a population of 65,000 people, so could 1,000 people speak for all 65,000? Is that really enough in order to determine that we do indeed have Jackson's favorite fries? I want to kind of go off on a side note for just a second, since we're thinking about that total population. Do you agree with me that we do not have to have all 65,000 people go through the taste test in order to make the claim? So it's great to be a skeptic and always be kind of questioning where some of this data comes from, but hopefully you're not skeptical to the point that you think all 65,000 people would have to take the test for us to make the determination about Jackson's favorite fries. In fact, a big part of what statistics does is it takes the information from a sample within the overall population and then allows us to draw conclusions about the population based on the data we've collected for the sample. Those two words right there are the exact technical words too. Sample, meaning the few that we've selected for our study, out of the overall population. So sample and population, two common stats words there. What we're trying to do is take the data from our sample and draw conclusions about the population. That's called generalizing, or we're trying to make generalizations about the population. And so that's certainly a valid use of statistics. So while I'm not convinced about the 10 people or the 100 people, I'm also not so far on the extreme skeptical side that I believe you have to talk to all 65,000 people. There would be a sample that would be able to stand in and be representative for the overall population. So let's say you get these kind of numbers. The manager of the Steak Escape franchise says, you know what? We had 10,000 people come through our taste test. 6,000 or 60% of them chose our fries, and only 4,000 liked the McDonald's fries. In our opinion, then, that was good enough to say, hey, we've got Jackson's favorite fries. Are you convinced? Would that be good enough to make the decision that they really do have enough evidence? Let me go one more example. What if those same 10,000 people were in the taste test, but 9,500 of them picked the Steak Escape fries, and only 500 out of the 10,000 chose the McDonald's? At that point, would you agree with me? You could say, boys, hang the sign. That's enough evidence to have the 95,000 people who, or 9,500 people rather, out of the 10,000 who like those fries. Well, here's what's going on in the concept that I'm trying to build. There is this idea in statistics where you reach a point with the data that it becomes not just different, but it's different in a statistically significant way, or it has a statistically significant difference. So even back at the very first example with the 6-4 split, I totally know 6 and 4 are different. 6 is indeed the majority and 6 is not 4, 6 is more. But it wasn't enough difference to be statistically significant. Now at this point, with the numbers like this, 9,500 and 500, I am pretty confident that their numbers are not only different, but they are statistically significantly different. And so what happens is there's some threshold that gets crossed. So there's a point at which the numbers change to where I now say, sure enough, you've got enough evidence, hang the sign. And that point is going to be the point at which we've reached statistical significance. Now, determining statistical significance is one of the great advantages of using SPSS. That's why we turn to statistical software to help us run these calculations. In fact, it's one of the limitations of Microsoft Excel. So in a lot of stats courses where Excel and SPSS are working hand in hand on different projects for doing different things, Excel does have some limitations. It cannot calculate statistical significance where the SPSS can. And so in this case, there is this some point at which we've crossed the threshold and we do indeed believe there's statistical significance. Now, it's not something that I can figure out just by eyeballing the numbers. It is something we need the software to do for us. So at some point, we've crossed this threshold in my examples of all the numbers to find that there really has been statistical significance reached. Whether it was the 6,000, 4,000 split from earlier or somewhere in between that number and these numbers here, we crossed the threshold. And that's what SPSS is going to help us to determine. You'll notice that two things are going on in order to get statistical significance. It's pretty easy to figure it out from this example. In fact, you may already be thinking about it in your mind and find it to be very intuitive. Even this trivial example helps to demonstrate what are the key elements to determining statistical significance. And you could imagine that in this study, we need two different things to happen. First of all, I need for the sample size to be large enough. The larger the sample size, the more convincing the evidence, and the more likely that we're going to be able to find statistical significance. But the other thing is, I needed the numbers to have this pretty good discrepancy. And so even if 10,000 people came through the taste test, but it was like a 52% to 48% split, well, that's not enough discrepancy to make the claim you have Jackson's favorite fries. And so I need two things to happen. I need there to be great enough discrepancy, and I also need for the sample size to be large enough. So we're not going to calculate this statistical significance level by hand. Instead, we're going to let SPSS do that and learn how to use the statistical software and the reports in order to determine if indeed we've reached statistical significance. Now, I want to make the distinction between the kind of stats that we're talking about now. At this point, we are talking about inferential statistics. Root word of inferential would be inference. Root word of inference is the word infer. And so what we're trying to do is we're trying to take just a sample and then infer from that how the whole population would likely react, or in this case, which fries they would likely choose. Make the distinction in your mind from inferential statistics to descriptive statistics. Because in earlier parts of our course, we were talking about descriptive statistics, root word describe, which was a totally different use of stats. The mean, the median, the mode, the standard deviation, the variance, those things are describing my data set. And so they are one form of stats. What we're now talking about as we bring a few out of the many from sample to population and making generalizations is inferential statistics. And what we're in essence doing in the inferential stats world is we're making a guess. You know, I didn't talk to all 65,000 people in the city of Jackson. I only talked to 10,000. And then I'm making a reasonable guess about what all 65,000 would think. Anytime you make a guess, you know what could happen, right? You could be wrong. And so what could happen is something really bizarre is going on with those 10,000 people that came through the study. They were biased, or there was something else that was flawed, and maybe they're not actually representative of the overall population. And if we make the claim that we have Jackson's favorite fries based on those 10,000 people, I could possibly be wrong. I could make a mistake. So what we're saying is, as we talk through the terminology in inferential statistics, this level of significance is what helps me determine, in essence, the percentage chance that I could be wrong. And so let's go one step further. We're going to call the statistical significance level the level of significance. Now, it has a couple of other names. It's also called the probability value, and for short, the p-value. So SPSS is going to determine that particular value. So interchangeably, we could use these words: the level of significance, the probability value, or the p-value. All three of those mean the same thing. And the concept is they mean the percent chance that you could be wrong. So in making a claim, our claim is simply about French fries, but the claim could be anything that our researcher is talking about. If we're engaging in inferential statistics, we're making a guess, and this is the percent chance that you could be wrong. Now, it's important to know in the field of education, we generally accept a p-value of 0.05 or less. And so what we're saying is, if you think about that in terms of a percentage, 5% chance. If it's a 5% chance that we could be wrong, or less than 5%, we're generally okay with that level of statistical significance. Of course, think about that conversely. It means it's a 95% chance that you'd be right. And so in education, we're dealing with issues where, as we research them, we're okay with a p-value of 0.05 or less. Now, in other fields or disciplines, they would be appalled at doing research at this kind of level. Like here on campus, as you may know, there's a school of pharmacy and there's a school of nursing, and we have a nurse anesthetist program. And those folks on that side of campus are also conducting research, and they're calculating p-values just like we are in education. But oftentimes in those fields, they would never accept a p-value of 0.05. Making a claim in pharmacy on some kind of research project that there's a 5% chance you could be wrong and being okay with that? No, not at all. They'd be looking at p-values of, like 0.01, maybe a 1% chance that their stats, or they could be making a false claim, or even possibly less than a 1% chance. But in our education field, the p-value 0.05, less than that, would be something we generally accept. When we make a determination at the prior to the study, so on the very beginning side of what our p-value is going to be that we're acceptable with, we call that the alpha level. And so oftentimes when you read studies, you'll see where the researcher writes that we determined or predetermined an alpha level of 0.05. That's just saying on the front end, we're making it very clear, if I get this probability value or level of significance 0.05 less than that, then I'm going to be okay and accept my study and go ahead and make the claim with statistical significance. So we'll work some examples so that you can see for sure what this looks like, particularly on the SPSS printouts and those kinds of things. But this is the concept of the level of significance, or the p-value. It's the percent chance you could be wrong. And it's some threshold that you cross. I can't explain what the threshold is. I don't even know. I can't go and draw the line and say, well, once you get to this point. But SPSS can. It can constantly calculate out with all of our data what the p-values are and let us know if we did indeed find statistical significance. So that's the idea of the importance of statistical significance, how it plays out in education.